see how my procedural word generation for my game is going to work. So this is my concept. So basically you have 4 cubes. Alright, we'll have 4 cubes, and all these have same dimension, and each of them have a unique ID. So like this has 1, this has 2, this has 3, and this one has 4. Alright, and this one is for straight road. Okay, this is for the straight one. Then we have the ones for going like left. Then we have one for going right. Oops. Then we have the ones that go right. Alright. Then we have the ones that like go upwards like a hill. Okay. So basically these are the 4 roads that we currently have. And just wait, we have one more we need. Let's take this one. Oops. Let's take this one here. Okay. So basically this one is for downhill. This one goes upwards. This goes downwards. Let's say this is 5. And these numbers are the unique IDs these each cubes will have. So all the 5 cubes are of same dimension, but they have same dimension as length and breadth, but their height will be different. And mostly the height will be different just for the hills, the up one and down one. So how this will work is that we will have a script which will generate a code. All right, it will have an sequence of numbers, like let's say 1, 1, 1, 2, 1, 1. Okay, so let's say this is the code, the script generated. So now we will have the first straight line, the second one, the third one. Then we will have the left turn. So basically it will look like this. Then again we will have 1, 1, 1. So this is how the script basically works, and this works with certain rules. Like if there is a 2 within, that means let's say we have 2 here. Okay, so now for the next 15 1, that means for the next 15 straight lines, there cannot be a next 3 or 2. Basically, if we don't have this condition, there can be like there can be one left, and suddenly we then can have a right. So with this script, if there is an left within 15 cubes, okay, as I mentioned earlier, each of them have the same size. So if there is a left turn, that means if there is an ID number 2 within 15 cubes, the ID number 3 will not spawn. This is how the script will be generated. So that's how the roads generation works. That's how the code for the ID series works. Now we need a method to attach each road without any height difference and like perfect sync. We need it to be smooth. So for that, let's just run this one. So for that, in each cube, we will have one entry point like in the same side and same height. Okay, I'll explain it in a moment. These are the entry points, and we will have um, we will have these as the exit points. Okay, so basically these two have few exceptions. So we will come to that in a while. So let's say this is the code we generated. Okay, so first we will have, all right, let's take another code just for an example. Let's say 1, 1, 1, 3, 1, 1, 1. Okay, 1, 1. That's enough. Okay, so here first we will have the red cube. This is from an not from a top perspective. This is from the side perspective. Okay, let's say we have dimensions that like this is the dimensions. Okay, so currently we are looking from this side. All right, so here we will have 2 points as we have marked here. This one is the entry point, and this one is the exit point. Okay, so this is the first one. Okay, we have marked this one. Now when the second code is generated and the block is spawned, that means the number 1 is spawned, again another cube will come, and the next cube's starting point or entry point will get attached to the exit point of the previous cube. And remember, all the cubes have their entry and exit in the same plane. So when these two get snapped, like let's say we snap these two, okay, we will still have the same plane. We will have the top as a single plane that is really smooth, so that we don't have any bumps or ditches in between. So here the road will look like this. Basically, you have this is how they will snap together, and again you'll have one of these. And now we have three here, so we'll get that yellow, I mean green, and let's say okay. So now I'll get this. Here it will get attached, and for the three, as we are having a right turn, like now it basically has to go this way. Okay, now the till now the road was going this way, but now it has to go down. So its entry point will be in the left side, and its exit point will be here. Okay, so now when the next cube is getting attached, I mean the one, it will come here, and now its entry point is here, and its exit will be right here. So when there is another cube, again it will go this way. All right. And now, as we have an rule that if there is a left or a right within the 15 cubes in its radius, that means let's say the code is already generated and it is 1, 1, 2, 1, 1, 3. If this is the code that's generated, and when the 3 is getting or trying to uh, be generated into the map, but it has an 2 within 15 range, that means within from 3, after 3 cubes or after 2 cubes, we have a 2. So basically, it is against our rules. So the 3 will be replaced by a 1. And again, the code will just continue. So basically, this code will be already working with along with the code generation. So like this will work with code generation. So the probability of getting an 1, 1, 2, 1, 2 is like it is not possible technically. But yeah, if something like this happens, this is how we get rid of it. Like it is how the code works. And with this rule, the final code is generated. We can put it out like that. So when the code is running, it will generate a sequence, like it will go first one, then we have a two, and now we have an like a something that that needs to obey the rule, that is we have a two here. So when generating the next few numbers, the script will remember that we have a two in the range and make sure that there is no more three in the way. So it will make sure that we have a one, we have one, we have one. Okay, so it doesn't really need to be a 15 block gap. We could even like decrease it to like three or four, or maybe put a constraint like within range, like let's say we need at least a minimum gap of 3 between two turns. So let's say 3 comma 15. So there can be different sizes of rows in between two turns. So this is how the basic row generation works. But when we come to the hill section, we have few exceptions, like for basically for hill, even if we keep an entry point here and an exit point here, so let's say a hill cube is like this. Okay, so a car goes from here to here, and again if the exit point is here, the car will have to fall down. So basically that's not how the roads work, so we can't do that. And that's why we have two hills, that is one that goes up and one that goes down. Still, let's say we have the entry and exit here, and the entry here and exit here. Okay, we don't want a hill that just goes like this and suddenly this. We need something that goes a long way, right? Like this should go the long way. So we need planes in between. So if this is the exit point and we already have planes with entry point in this level, we can't make it come all the way up here. It will break the way the script works. So basically, let's just increase the size. Okay. So basically, for the hills, let's say this is the hill. Okay. That's not how I want it. I want to split. All right, I will draw it. Let's say we have blue as the hill, right? Okay. So this is the hill cube. Okay. Here, so basically this is how the hill cube will look. And if we put a plain cube next to it, this is how it will look. Okay. So here, the exit point, the entry point will be here, here, and the entry will be here and here. Yeah, you might think like, no, this is not what you said. So basically, yeah, I made a mistake. So this is not where we have it. We will have the exit point. Here, we will have an exit point right here. And keep in mind, the distance between these two, that means from the base of the straight cube to the topmost of the straight cube, let's say it is x. Then the distance from the uh, road bottom side, like the lowest part of the hill to the top part of the hill, will also be equal to 2. So basically, the total height of the hill's cube is 2 times the height of the normal cube. So that this is so that like the mathematical functions are like the way we do the logic is much simpler with this, because if you put like 2 and then you put in half here, we will have issues when there is a procedural generation. So now after this, let's say we are our script goes like this. Okay, our series, the code goes like 1 1 4 1 1. Okay, it's not over. There is more. Let's just say this. This is the one. So this one is this cube. This 4 is this cube. Okay. So now we have 2 more. So let's just draw that. Okay. Just don't mind the shape. These are all of same plane. They are all in the same plane. I don't think the helical node is steep. It will be smooth. Okay. So basically now after 2 red. Okay. After 2 straight lines, like these both are straight. This is straight. This goes up. Now we have another rule that will be set that if there is an uphill or if there is an ID number 4 within a range of, let's say, 4 to 12, then another 4 or 5 should not spawn. Anything else can be spawned. Okay, so there can be a 3, there can be a 2, but no 4 or 5. So basically, for the next like 4 to 12 cubes, they are going to be basically a plane. And after the 12, a 4 or a 5 can be spawned. So let's say we already have 14 here, like or 4 here. So next, let's say we have numbers in between. Okay, and finally, after getting 5 in between, 5 cubes in between, now we can spawn a 4 or a 5. Okay, yeah, it's exactly what I said. 4 or a 5. You can basically go even more higher, or you can go down, or it can just go like it can keep on going. Okay, like the base level of the game will totally change to this level. And if there is a 4, we will go up. But if there is an 5, let's say we have 5 here, we will have the purple. And for the downhill, we will have this cube. Okay, so now here its entry point is right here, and its exit point is right here. And keep in mind that this distance is same as this distance. Okay, so now let me just extend it. So now when we have another code right here, like let's say after 5, let's say we have a 1 and then 1. Okay, so again it can generate the road as 2 more straight blocks. So this is how it basically works. So yeah, and now we have few other things that we need to consider. Like let's say we have like this series is going to keep on going. Okay, like 1 1 1 1 4 1 1 1 1 5. Like it's gonna keep on going, right? It will just keep on going simply as much as it drives. So we need a way to optimize it. Like if there is 1,000 cubes behind you, then yeah, you're gonna need a hell of a piece. So basically, we need a way to discard the ones that you left behind. So for that, we will be using a method called pooling. So basically, there we go. Okay. So basically, for that, we will be using a method known as pooling. Basically, what happens there is, let's say you generated this much world, okay, and currently you are here. Let's say this is your car, okay. So now you don't need the roads like all the way over here. You don't need them. So basically, a single model, all these generated models, they will just so basically the pooling goes like this. Exactly what we say. All these models will get to a pool. Okay. the ones we left behind, they will come into a pool and stay there. And when there is a sequence that needs a similar one, like let's say we have another, the sequence goes like here is one, we have a four here, we have one, we have a one, we have a five here, we have a one, we have one. So this one is the code for this current generation. Okay, so let's say now currently we have pulled these four. Okay, so now when the series gets to a number like a one, another one, another one. Okay, now we need three new ones. And if you try to generate a new one for each series of each ID, like it is gonna need a lot of GPU memory, and like we need to literally spawn one. Like we are creating one, so basically we need a lot of power. So instead of creating a new one, we will take the ones we have, three ones in the pool and one four in the pool. Okay, so now all these three ones will get here. So basically you just reuse them. So if you try to go back, you won't see this one. So in order to avoid the players going back and falling to the pitch, we will be using a mechanism that most of the these infinite drives or like endless drives use. We will have an infinite barricade over here. So basically when the player comes back, they will just hit here and they would have to go back this way. So after these three, let's say we have a four in the code. So now this four will come here. So basically you don't have to like keep on generating newer models for each series. So this will make sure that this is efficient.